does work, but it kind of anchors me to that. And I'm basically doing like I'm doing when I'm just teaching a lesson right here, like kind of like it was in the spring. Anyway, I'm just kind of talking to myself over here as opposed to you. So I kind of like this a little better. But we'll see. Once everybody comes back, hopefully in a couple weeks, then I don't have to video this class because I don't have virtual people in here. So at that point, I can just kind of roam around and use the whole board or whatever. So, how are we feeling right now? Okay, I looked at the homework questions. I don't know why I gave some of those. I don't know. They're pretty brutal for considering what we've talked about. And I don't know if I was a day behind or whatever, or maybe I know I'm leaving some things off this year because every year I reevaluate after seeing another AP test and realizing they just don't ask that anymore. Why am I? Because they might have asked it 15 years ago, but it's a little bit different. They tend to focus on different things as they evolve. So anyway, let me get this. Anyway, so I hope I was able to answer those questions. I actually have videos for most of those questions. Was it somebody in here who asked about them? Might have been the other class.
I mean, I stayed and asked one question.
But I actually went back and made a video of like the 25 and the 21 and the 27 and all the 27, don't worry about it. I actually went back and eliminated. That will never show up on a calculus homework again. But a couple of them are a big deal. And if you didn't get this part I really do need you to see. And tell you what, let me find something to link right here. I do need you to be able to rationalize this kind of stuff. And this may show up as a test question that is not a bonus. So what if I were to give you something like, now that may show up, because that's not the ugly one like on number 25 where you had no denominator, right? You had to kind of rationalize just to get a denominator, just so that you could actually apply the rules you know for infinity, which tends to look at powers, because powers affect that end behavior, right? On this you can do it. Now, the square root's in your way, so what can you do with this square root to kind of help yourself out? Well, I'm not going to do any rationalizing because, again, I'm going to rationalize in two reasons. Either I want a denominator, I already got one, or I got 0 over 0 and I'm rationalizing so that I can cancel a whole out. Neither of those are in play here. I've already got a numerator and a denominator, right? I can't really apply my rules for powers because the square root's in the way. So what is the square root of something squared?
Just the x.
It's not 4x, it's the absolute value. Like if I had just had that, it wouldn't just be 4x, it would be the absolute value of 4x. And we mentioned that for the people who hung around. A lot of you guys were trained wrongly in Algebra 1 and Algebra 2, and maybe even in Pre-Cal. And I know why, because when you're dealing with Algebra 1, you're dealing with a huge body of people, and some of them are really struggling. And this is really a 5-step question. If I were to say solve, most of you guys went, oh, well, you square root both sides, and you get that. And I can hear my Algebra 2 teacher saying, don't forget, if you square root both sides, don't forget the plus or minus. But you just skipped 3 steps. Now you may go, what do you mean I skipped 3 steps? Yeah, these are the 3 steps you skipped. And this is why it's plus or minus 3. But the problem with just showing this and never talking about anything else is you start thinking that the square root of 9 is plus or minus 3. Ask your calculator, what's it going to tell you? 3. It's not going to say plus or minus. And you start thinking the square root of x squared is x. No. What's the square root of x squared? Absolute value of x. What's the square root of 9? 3. Now technically you can say the square root of 3, but the square root of 3 is 3. But what's the definition of absolute value, tell me? Sometimes it's positive, and sometimes it's negative, and then that becomes a negative 3. And that's where the plus or minus 3 comes from. That step, simplifying that, and then saying, oh, x is plus or minus 3. But we get sick of writing all that, so we just jump from here to here. But see how this is in play. And let me show you one other thing if you didn't catch this yesterday. What does the absolute value of x graph look like?
It's a V.
It's a v if it was like y equals, right? And this function stands for a y equals. I don't say that, but I'm looking for the y value that as it behaves on a function like this. So doesn't this kind of mean, isn't this graph right here the y equals x graph? And isn't this the y equals negative x graph? So isn't this sometimes y equals x and sometimes y equals negative x?
Yeah.
Except it's just limited, right? Instead of going forever. You tracking with me so far? Now what is it x? You can say for positive values of x, but doesn't it also mean it's x as x approaches infinity? And doesn't it mean negative x as x approaches negative infinity? So if that's the case, when you look back up here and I square root this, by the way, I know that that's absolute value of 4x. So I got to figure that this other junk, it does something, but I really don't know exactly what it does. So I'm just going to go, it's 4x plus or minus something, but you'll see that the something doesn't really matter. And then I drag this other stuff down. Now I'm one step closer to victory here, but I still have this absolute value in the way. Well, if I'm going to infinity, like my graph suggested, I would be using the 4x part, right? If I was going to negative infinity, I would be using the negative 4x part. But I'm going to infinity, so I can get rid of the absolute value part. And now, I've gotten rid of square root, I've gotten rid of absolute value. It's all about matching, looking at your powers. So when I simplify all this together, what do I end up with? 7x minus some junk over 6x minus 3, which technically I don't care about that anymore, do I? So the junk didn't matter to me, because whenever I go to infinity or negative infinity now, whenever the powers are the same, I take the coefficients. So you've got to be able to do this. And I'm not suggesting it's going to be this big and ugly, but remember, the only reason I rationalize is if I have a whole that I don't know how to factor. When I rationalize it, all I'm doing, do you know that when you rationalize something, you're not changing it? Because you're multiplying the top and the bottom by the same thing, right? So you're not changing the actual value of the fraction, you're just changing the look of it. And by changing the look of it, I'm able to cancel out the whole, right? And then on that really ugly problem like number 25, and by the way, if you just want to erase that from your memory, the 25 and the 27 or whatever, it's only going to be a bonus question. If you're confident about it, awesome. If it shows up as a bonus, you got a couple extra points. But I'm not going to test you on that, okay? But it also, in situations like this where you're like, man, I want to know about my powers. I do have a fraction, but that square root's in the way. Well, I can get rid of that. Oh, now the absolute value's in the way. Ooh, I can get rid of that. And then, so like if this had gone to negative infinity, I would just written negative 4x. And then when I added these together, I would have a negative x over 6x, which is negative 1/6. Y'all seeing that? But definitely know how to do this. There's other ways to do this problem. They're very algebraic and to me a little bit longer, and you still at some point have to recognize infinity, positive, negative infinity, negative. You're still going to have to do that, but to me this is the easiest way to go. If you want to know another way, come see me or something. All right, so today I want to talk about, anybody have any other questions on anything? We're starting to get there. I will say this, if you can do all the worksheets I'm throwing at you and you can do the problems on those worksheets, that's the more on the lines of what you're going to see on your test. And I have a couple of different reviews I give you and a lot of different stuff we're going to do in class and throughout the week. But your test is coming up. We only have like a couple more days of stuff or whatever. Isn't it Monday, Tuesday?
No.
Oh, Tuesday, Wednesday. Is it Tuesday, Wednesday?
Next week?
Next week, is that
It's
when the test?
Tuesday, Thursday. No Google Meet.
For us, it's Tuesday, Thursday.
Yeah.
We have school.
Yeah, but I'm giving the test on Tuesday for you guys. Is that right? I'm so far. Oh no, you're right. You're right. Okay. So yeah. So right now we're going to be learning a few more things about like continuity, but we're going to be practicing on Friday. I know it says group work, 6 feet apart group work. And then we're not here Monday. And then we work on a review sheet Tuesday. You will be here for that. And then I have a practice quiz on Wednesday for you to take at home. The key is there. And I actually went through, I have a video of me working the solutions. Well, actually, I have the solutions, and I'm walking you through what I did on the solutions. A video of that if you want to see it. And then there's another review sheet that you can work on. So lots of practice, but today is going to be a little bit different. And then I guess you guys will take your test Thursday. And then on Friday, I'm giving you the day off. So, so I don't love to do that, but I'm underwater. I haven't left here. I have not worked. I worked 11 hours a day or more for as long as I can remember, and I can't. I'm drowning. So it's not sustainable. So I don't have any more time to make any extra videos to pad. So whatever. Here we go. But I did cut something out, so I don't think we're behind. I cut something out that was kind of, I don't know if it was a waste of time. It wasn't useless, but it was like a whole day of practicing those really brutal problems that show up once every 10 years. And I'm like, you know what? If anything, all it does is just combobulate your brain. And I'm going for some new strategies in the era of COVID. So here we go. What happens? Yes.
I do have a couple questions, but if no one else does, could I come maybe fifth period?
Let's just look at it. That's a good question, actually. I see what you're asking. And you might know how to do it based on what I just said. So think about this now. Say I'm going to make up a different problem. This was not what you had, is it? Okay, so what if I ask you that? You plug a 5 in and you get what?
A hole.
0 over 0. So you're thinking there's a hole. And it kind of is, but it's actually not. It's a jump. And a jump is this. Like a jump is when you go in from one side and then jump to another. And one of them might be filled in, but that's what we call a jump. Jumps do not show up on polynomials or rational functions. They show up on piecewise functions, which is what we're doing today. And what I threw that out was just to kind of see if you could check out what absolute value means. So the first, maybe what I asked you first is what's happening from the left? So I thought of this. Okay, if at 5, you plug a 5 in there and you get a hole. You're thinking, okay, well I might be able to cancel that, but before I cancel it, let me think. I'm coming in from the left side of 5. And if absolute value does this, the right side of 5 would be the x minus 5. The left side of 5 would be the negative version, right? So if that is where the 5 is, and I'm coming in from the left side, then what do I want to use?
The negative x plus.
It's kind of like if I was going to negative infinity, I would use that. But anything to the left of it, I got to use that. So I'm going to replace this value right here with negative x plus 5. Now, that I can factor. I can pull a negative out, and what happens? The x minus 5 cancel, and what am I left with? And anytime I have a constant, the limit of a constant is the constant. So the limit from the left side of 5 is negative 1. Now, what happens if I ask you about the right side of 5? Well, on the right side of 5, what is absolute value?
X minus 5.
Just the x minus 5. Well, from the right side of 5, I don't have to change anything, do I? And then they just cancel and leave me a positive 1. So from the left side, I ended up with a negative 1 y value. From the right side, I ended up with a positive 1 value that I was approaching. Well, guess what this graph looks like? Now that's a common enough AP question that I just remember that. When I see that, I go, oh, it's one of those, because it always cancels, right? It's going to cancel whether it's negative or positive and give you a 1. Think about it. If I plug a 7 in there, 2 over 2, 1. If I plug a 20 in there, 15 over 15, 1. If I plug a negative 60 in there, positive 65 over negative 65, negative 1. It's always going to be 1 that way, negative 1 that way. You just don't make the mistake of just canceling it and saying, oh, it's 1, the limit's 1. No, the limit at 5 is what? D and E, because it's different from both sides. That's actually a kind of a common AP limit. I've seen it a dozen times in my memory. It's not guaranteed to show up, but I tell you this, it has never not shown up on my test. I will tell you that. Hint, hint.
Wink, wink.
Star those little bonus questions from the quiz. All right, so anyway, here's what we're going to talk about today. Today we're going to talk about, we're going to kind of go back to the very first day. Do you remember the very first day when we did graphical limits? And I gave you this atrocious looking graph that had all kinds of weird junk going on? Does that graph ever show up from a simple polynomial?
No.
No, polynomials just do this, right?
Yeah.
Does it ever show up from a rational function? Maybe, because there were some vertical asymptotes. But do you ever get stuff like this on a rational function?
No.
No. Rational functions basically go left, right, maybe they flatten out, but they might have a VA, maybe a hole, but none of this junk, right? So if I give you a really ugly graph, I'm essentially giving you a piecewise function and saying find the limits. Well, what if I give you a piecewise function, but you don't know what it looks like? And you don't want to take the time to see what it looks like. That's what we're going to talk about today. So check this out. I'm giving you this piecewise function and I'm asking you about limits. All right? So what do? I don't know what it looks like. Now you might go, well, you could graph it. You could. But I can tell you that a lot of times on these, you're not going to have the time to graph it. All right? And if you take the time on this, you're just not going to finish another problem. But what really matters on a piecewise function? If I say find the limit right here, find the limit at 2, and it's a piecewise function, and you can see that at 2, different functions went with different sides. Does that make sense? So what do you think x minus 2 means? X less than 2 means?
It's less than 2.
So it's to the left of 2. That'd be like x approaching 2 from the left side. I would use this one. And x greater than 2 would be on the right side of 2, right? So that would be if I was looking for the limit as the function approached 2 from the right side. But if I want to know what happens at 2, what do I have to check? The left and the right. And the only way that limit would exist is if I found the same, it was heading towards the same place. Does that make sense? Yes, no? Well, what is the equal good for when it comes to finding a limit?
If it exists, like if
Oh.
there's not a hole.
You made a true statement, but here's the question. What does the equal of, how does that affect the limit?
If it's continuous or
The limit.
it doesn't.
It doesn't. Okay? So it affects continuity, which we're going to talk about today, and it affects the value, which is what George said. So good points that we will get to. But it doesn't affect the limit because do we care what happens at the value? No, we care what happens as it approaches that. So check this out. What I'm doing here, this nice setup for you, is I'm showing you what you would normally do if I just asked you this. Because unfortunately, I can't, on a normal function, I would just plug 2 in. But on this function, it's not a normal, it's a piecewise function. Do not plug 2 in. That's where it's equal. I do not care that this function is at 2, because that's not a limit. Now, I do if I ask you this question right here. What's f of 2? Yeah, plug 2 in, and what do I get? 2. Merry Christmas. I actually didn't even have to do anything. Y equals 2 when x is 2. If I ask you something like this in part D, what's f of 6? Well, which function do you think 6 would go into? The bottom one, plug a 6 in, you get 3. But that has nothing to do with limits. It will affect continuity, like George said, and it definitely affects the value, but not the limit. So if I want to know the limit at 2, I need to check the limit from the left and the right, because there's no telling what happens on a piecewise function, right? Unless you graph it, and I don't have a graph. So let's check from the left, and that's why I asked you part A. I was just trying to get you in the habit of seeing that when you find a piecewise function's limits, you've got to check both sides. So what is 2 from the left? And again, don't plug in 1.9. When do I plug in 1.9?
If it's approaching 2.
If it's approaching a vertical asymptote and you know it's going to infinity, right? And I don't even know that I'm doing that yet. So let's plug in a 2 and I get what? 1. Okay, great. So the limit from the left is 1. What's the limit from the right side of 2? Oh, plug it in here in the bottom. 2 over 2. That's also 1. Well, if the limit from the left and the limit from the right are the same, then the limit as I approach 2 is what? So does it exist? Yes. What is it? 1. And that's how you find the limit on a piecewise function. Not a really big deal. Now, what you're also going to learn today is this. If the limit from the left and the right is the same, which means the limit exists, and the value at 2 also exists, which it does, and the limit and the value are the same, which they're not. But if they were, you would say the graph is continuous there. Now, if you had to draw a picture of what's happening here, here's what I would draw. I would say, okay, here's 2. From the left side of 2, it was heading right here towards 1. And if I look up here, I'm like, oh yeah, that was a -1 slope. So it was probably doing something like that. From the right side of 2, I was also heading to 1. And that's a 1/2 x, that's a positive 1/2 slope. It was probably doing something like that. But at 2, the value was 2, right? So at 2, I was actually up here. And that kind of stuff just doesn't show up on regular polynomial or rational functions. You don't see that. That is a piecewise behavior. And yeah, I could have graphed this if I wanted to, but I don't really want to. Are y'all with me so far? Okay, what about this one? You'll notice this one, they gave you a function and they included the equal with the inequality. So let's start with part A. What's the limit of the function as I approach 1 from the left side? Ooh, dne. So right here, what does 1 over 0, hold on, what does 1 over 0 mean? We're not going to write dne. It's true, but we can write more. That means there's a VA coming in from the left, right? So how do I check if I'm going to negative or positive infinity there? I think, what would I plug in? Like a 0.9? Because that's a little to the left. So if I plug, I can't just say dne. It is dne if I was going from both sides, but look, this graph doesn't go from both sides, just from the left, right? So let me check 0.9. What do I get? Well, I still get pretty close to 1, but if I plug a 0.9 in there, what happens?
Negative.
So I end up with a plus over a minus. So what do you think's happening from the left?
Negative.
I'm going down on that asymptote, right? So negative infinity, down from the left side. Now, what about from the right side? So from the right side, that's the greater than part. The equal part didn't really matter that that's there, but the greater than part would be this. If I plug a 1 in there, I get 1 minus 2 plus 5, which is 4. Correct me if I'm wrong on any of this. So does the limit exist? No. It's not approaching the same y value. So does it exist? Absolutely not. Why not? Because the limit from the left and the limit from the right were not equal. But can you find f of 1?
Yeah.
Yeah, it's equal, also in the same space, so it's definitely 4. Can you find f of -1? Yeah, you can plug, but you use the top equation. So 1 over -2, so negative 1/2. And if you don't know this already, don't write 1 over -2. Negative on the bottom is like chewing with your mouth open, right? Or whatever other bad etiquette you could have in math. Keep the negative on the top or out to the side. All right, what about, let's look at number 3. All right, so you'll notice on number 3, well, no, I'm still doing it. Eventually, I'm going to probably just say, hey, does the limit exist at blah? And quit asking me to check left and right. But I'm just trying to build some good behavior here. Piecewise function, who knows what's going to happen? Looks like a line from the left, a line from the right with different slopes. Let's check. From the left side of 2, is there a limit?
Yes.
Yes, and it's equal to? From the right side of 2, is there a limit?
Yes.
And it's equal to?
2.
2. So does the limit exist?
No.
No, why not? The limit, yeah. The limit from the left and the limit from the right are not equal. All right, what about number 4? Is there a limit from the left of 2? So there's a VA, right? Because you got 1 over 0. So what do I have to do? Plug in like a, and yeah, don't say dne, because remember that was a trick. If I know there's no, if that was the only function, I know that there's not a limit there because it's doing this, right? Or maybe this, right? I know that, but I'm only looking on one side, so it's got to be infinity or negative infinity on just one side. What happens when I plug a 1.9 in there? Positive over positive, right? So this is actually going to infinity here. What about the right side of 2? I get 1. So does the limit exist? No. Why not? left limit and right limit are not equal. All right, what about number 5? Now this is a great AP question. They love to ask this stuff. And I'm not kidding, I mean, they love it. It's like, they get down, they're writing their test, and they need a couple more questions, they're like, oh yeah, we'll put that one on there. They'll actually go a little bit further. They'll start asking you for what value of A, not just where they exist. When you get to derivatives, they'll say for what value of A is it differentiable? And you'll have to check another thing. But if I just want to know for what value of A does that limit exist, well, let me think. To exist, what has to happen?
The left and right limit.
The limit from the left and the right have to be the same. So let's do that. Let's say, all right, the limit of this from the left, right here, has to equal the limit of this from the right. So let's see, if I plug a 1 in, what do I get?
30.
Careful.
You need a negative one?
Oh, sorry, if I plug a negative 1 in there, what do I get?
3.
Negative 1 plus 4? 3, yes, sorry. And then if I plug a negative 1 in there, what do I get?
Negative 2.
Negative 2 plus A, whatever the heck A is. A would be a constant, because it's not the variable in question here. So by default, it won't be a variable. It's always assumed to be a constant. So if I plug a negative 1 in there, I get negative 2 plus A. And you just told me, in order for this to exist, the left and the right sides have to be equal. So what must A have to be? Now here's the problem with a lot of you guys in the past that I've taught, is you're really bright people. You're an AP Cal. It's a very select group. We have 38 AP Cal people, another 5 or whatever virtual, and then some B. So you're talking about 50-something kids in this school out of a class of 300 and something. That is the top 20% of the school without question. Okay? So a lot of your life, you have just been looking at stuff and writing down answers. Well, this is how AP would give you credit here. They're going to give you 1 point, say, on this for finding the A value. But they're also going to give you 1 point for saying what the heck you're doing. But a lot of you don't think that way. You're like, oh, from the left it's 3, from the right it's that, A is 5, and you don't write what you were doing. And you lose half your credit on a 2-point problem because you didn't say what you're doing. You have to start saying what you're doing. This part doesn't even, a lot of people assume, oh, well, you know, right here, you can find 3 and find negative 2 plus A. They probably won't even give you credit for that work. It's more important to say, hey, I'm showing that I know for a limit to exist, the left and the right side of the limit have to be the same. It is really important for you to speak what you're thinking. And I know you're like, but it's so boring, and it's such a waste of time. You are correct, but you're not going to make a good score in this AP test without saying what you're doing. Pretend like you're talking to a moron, okay? You have to say, even if it seems redundant to you, show those steps on problems, okay? I give a lot of grace in the first semester with that. I got the answer. Yeah, if I could have gotten the answer without work, a lot of times I'll start giving you credit, but at some point I'm going to go, nope, I'm going to start literally pointing out a problem. What I mean when I say pointing out, I mean assigning points to different things. And if you don't have it, you don't get it. And it's a really good way to get hammered on a test, is not showing all that work. So be careful with that. Okay, definition of continuity. My students will probably remember this. I think I may have even talked about this in a video at some point that I have out there, but if something is continuous, it means that it's flowing smoothly along, right? Like that would be a continuous function. Smoothly along, forever to the left. That is a continuous function on the negative infinity to infinity domain. Now, some functions aren't continuous on everything. They're continuous on certain parts, like a rational function, maybe that has a vertical and a slant asymptote. It might come along like this and zip up, and it might come along like this and zip down, and it's continuous everywhere except where? Right at the breakpoint. And sometimes they have other breakpoints. And piecewise functions, but they could have breakpoints everywhere. But think, if as I draw the picture of this graph from negative to positive infinity, if I ever have to pick up my pen, and by the way, I know technically on this whole I don't have to pick up my pen. But you know what I mean, right? A real hole would be like, I literally would have to pick up my pen, hop over the hole to the other side, right? So if there's anything that causes you to pick up your pen, that would be a place where it's not continuous. Now you can see that stuff easy if you have a graph. But if you have a piecewise function, you might not be able to see it. So what do? Let's think about places that are continuous. So right here, this point is definitely continuous. But think about it. The limit exists, right? The limit is a real number. You don't have to write real number, you can just say it exists. That's what a real number means. But it exists because you can see it from the left and the right. I went to the same spot. The actual value there, the y value, also exists. And you can see that, look, there was an actual point in there. And the limit that you got and the value that you got were the same. Right? The limit here and the value there were the same y value. Now, look at this situation. Does the limit exist at that hole?
Yes.
Yes. Does the value exist at that hole? Yes. Does the limit you got and the value you got equal? No. And clearly it's not continuous there because what did you have to do? Pick up your pen, right? To graph that? Look at this. What if the graph did something like this? And again, you can't see the picture. I can look at that and go, of course that's not continuous. Look, there's a jump there. We call that a jump, or a jump discontinuity. But if I had a piecewise function and I couldn't see the picture, couldn't I say, does the value exist? By plugging the number where it's equal in and go, yeah, the value exists. Does the limit exist? Check from the left and the right. Oh, it doesn't. As soon as one of these 3 points of continuity, it's like the limit would not have existed on this. And if the limit doesn't exist, then there's no way that they're equal, right? These are what we call the 3 points of continuity. For some reason, people like to write these all out. Don't do that like this. Don't say, hey, the function is defined at the point, and then give me something. Just say, f of a exists. That means the function at that x value exists. Don't say, hey, the limit must exist at that point. Don't say that. Just say, limit of f of x as x approaches whatever a value, x value we're talking about, exists. And at the end, don't say, they're equal. Okay? I'm going to go, who's they? Okay, say, the value of the function at that point, f of a, must be equal to the value of the limit at that point. Limit of f of x as x approaches a. I cannot remember an AP test where at some point they didn't give you 3 points for answering this question. I'm like, 3 points is a ton of points. You have 108 points on your AP test. Traditionally, which I'm guessing it'll be like that this year, because we'll find a way to be able to test normally. I'm pretty confident. Okay? Curves flat. Right? 108 points. Guess how many points you need to pass this thing? With a 3? 40. That's it. And you pass and get college credit at a lot of schools. Guess how many points you need for 4 if you plan on going to like a private school and need a 4 to get credit? This is typically. Sometimes this is like plus or minus 2 points, whatever. 54 gives you, that's half. You can miss half your points to make a 4. And for a 5, I've seen it as low as 66, and I've seen it as high as 73, but it's typically around 69 or 70, right? Give or take, whatever. That's still allowing you 38 points to make a 5. A 5, okay? So this is 3 points. That's 1/13 of what you need to know, and it's always on there for maybe not always 3, but it's usually 2 or 3 points. All right? So, and I'll ask this, I promise you, okay? What are the 3 points of continuity? All you got to do is write that exists, that equals that.
On the AP test, is it okay if we just write the numerical form of it? Or like without like writing it out in sentences?
Dude, I would never write it out in sentences. Ever. I would always write this. And sometimes it's not so obvious. They're not going to say, write out the 3 points of continuity. They're going to ask you a question. It's like, why do you know this is true? And you're like, well, because I've checked my continuity. The 3 points of continuity say that. If those 3 things check off, I know the function is continuous. Okay? Also, discontinuities on a graph usually fall into 3 ways. and they have names, okay? So the names are this. If you ever have a denominator equal to 0, whole or vertical asymptote. Holes in vertical asymptotes are places where the graph is interrupted. So if there is an interruption, you know there's going to be a discontinuity in the graph. Okay? And so all of these situations, logarithms, where it's not defined, square roots, even roots that have negatives, gives you imaginaries, all those places where the domain didn't exist, those are situations. Asymptotes of trig functions, tangents, right? That keep doing this over and over again. Any place there's an interruption like that, places where the domain was broken, those are discontinuities in a graph. But we have names for them, just to show you. There are jump discontinuities. Jump discontinuities are places where the graph literally jumps at -1, jumps at 2. Right here, technically it's kind of jumping at 4, but I've really never seen AP mention that. Jump at 5 from the left. You know what? I probably got to go back. AP would only talk about like -1 and 2. They wouldn't talk about the rest of these. They technically are, but they avoid situations. -1 and 2, where literally you hop from one directly down or below it or directly above it. Infinite discontinuities are places where there's a vertical asymptote. Now, 4 has an infinite discontinuity from the left, because it is a vertical asymptote from the left, but from the right, does it?
No.
No, if you saw that, you wouldn't think vertical asymptote, would you? So just from the left would be, but they will only talk about stuff like this on your AP test. Literally where there's an asymptote from both sides. Now this is kind of odd. A removable discontinuity. I don't know, you don't really remove it, but they call it a removable, and the best guess I can make is because I can do something like this. Removed it by coloring it in. So removable discontinuities, like right here, I could take this and go, removed it, right, just by filling it in. Now there's not a discontinuity there. Moves it right through it, right? I don't know why they call it that. I don't know why they just call them whole discontinuities or point discontinuities, but they almost always call them removable. And you can see that at -5 and at -3. Okay? Okay, so let's just take a look at these and see if we can talk about all this put together. And I got 12 minutes. I feel like I'm in a pretty good spot today. All right, so let's see if we can buzz through these. And I'm kind of doing this. I'm working down. So even though they're numbered across, I'm thinking down right here. So who can tell me the value of f at -3? The value of f at -3. So there's equal -3. Plug it in, -2. That is not a limit, that's just the value. So the value exists. Right? All right, who can tell me the limit at -3? What do I have to do to check that? So check from the left, which would be the top equation, which is -2. Check from the right, which is the second equation, also -2, right? Same left and right, what's the limit? Oh, so you're saying the limit existed. So the value existed, the limit existed. Is it continuous there? Why? Because they both existed and they're what? They're equal. So is the graph continuous? Yes. Now if they say prove it, what would I say? F of -3 exists. The limit of f of x as x approaches -3 exists, and the functions -3 and the limit f of x as x approaches -3 are equal. I would just write out those 3 statements, like you saw earlier. What about at 0? What's the value at 0? 1. That's where it's equal. What's the limit at 0? I check what? From the left and I get a 1. From the right, I get a 1. So the limit exists. And if the function exists and the limit exists, yes, it must be continuous. What about f of 1? Oh, there is no equal. So the 1, the value does not exist. Well, if the value doesn't exist, then you know right now it's not continuous. Because if any one of those 3 is not true, then it is not continuous. But I can keep going. Is there a limit there? From the left of 1 is 1. From the right of 1 is 1. So there is a limit. It's 1. So what would this look like if I was sketching the graph? Good. It actually is coming in from the left, leaving, so there is a limit, there's just not a value in there. And there's not a value above or below it, there's just no value. So it would kind of look like just a hole right there, for what it's worth. And then f of 2, what's the value of f of 2? 3. What's the limit of f of 2? Well, from the left it's 0, from the right it's 3, so that does not exist. And again, if any one of those doesn't exist, then the graph is not, no, it is not continuous. Y'all with me? What would this look like here? A jump. From the left I got a 0, so it's coming in from the left, it looked like that, right? From the right I got a 3, and it existed there. Looks maybe something like that, right? But there wasn't a limit. So it's not continuous. Jump discontinuity. So this is a big, ugly piecewise function. Let's see if we can run through this bad boy here. Okay? So let's check it all out. Now, some of you might have gone, man, I could have just sketched these graphs. They'll get increasingly harder to sketch, won't they? So let's just check it out. The limit of the function, -5 from the left. What do I get? -3. Negative, I'm moving left to right now. -5 from the right. -3. What's the limit as I approach -5? -3. What's the value of f of 5? Oh, sorry, that's supposed to be -5. Sorry, put a negative in there. Also -3. So would this have been continuous?
Yes.
Yeah, I don't think I asked that. Oh, I did ask it at the bottom? I can't see it right now. Okay, so what about, yeah, that's right. So what about the next one? What's the limit as I approach -1 from the left? 6/2 is 3. -1 from the right. -9/-3, which is also 3. So does the limit exist? Yes. Does the value exist? No, there's no equal sign on either of those -1s. So no, that doesn't exist. So is this continuous here? No. There was a limit, so it looks like there's probably a hole there, but the value didn't exist. And then what about -3 from the left? So 3 from the left, I get -5/5. What's -5/5? -1. 3 from the right, I'm going down the bottom equation. I get 18 minus 15 is 3/-3. Also -1. So does the limit exist? Yes. Does the value exist? I go to =3. Yes. So is it continuous there? No. Because if the limit is -1 and the value is 1, then a couple things are right about the continuity check, but definitely not the last one. Y'all seeing that? And if somebody said, why is it not continuous? Then you could say, I would say this. The value of 3 is not equal to the limit of the f of x as x approaches 3. A lot of people put a 3 in there. Don't do that. Just say the limit of the function as I near 3 is equal to the value at 3. Not true, and that would be a proof for why that would not be true, if somebody asked. Now here's where it gets a little tricky. Where on this function, give me the actual intervals where this function is continuous. People hate this question for some reason. Now let me ask it, okay, I'm going to ask it again. Where is this function continuous? Or I also might ask, where's the domain? So first I'm going to say, where is it continuous? And then next I'm going to answer, what is the domain? So can you tell me what this is here on the right? What is this telling me?
Different intervals.
the different intervals where that exists? What does that sound a whole lot like? Sounds a lot like domain, doesn't it?
Yeah.
Now, there might be certain things within the function that mess you up, like what can't go in here? -3? Is -3 in that interval? Okay, well, you got to consider that. What can't go in here?
A 2.
A 2 or a
Negative.
-2. Well, a 2 can't go in there, but a -2 is not even in that interval, so I don't care about that. And then what can't go here?
6.
And 6 is in that interval, isn't it? So all this stuff here is kind of a hint at the domain, but it's also talking about continuity. And didn't I just check a whole bunch of continuities here? So watch me write continuity here. Okay, I'm starting at -infinity. Now, there are no breaks in this because this is a line. So I'm going right up to the -5. Was it continuous at -5 when we checked it? It was. So I'm not going to stop at -5. I'm going to keep moving. I'm going to keep moving all the way through the -1. Oh, wait a minute. There was a vertical asymptote at -3. So it's definitely not continuous at -3. I'm going to break it there. And you can put a union or a comma. AP's a little sloppy, they just put commas. Now, as I get to -1, was it continuous at -1? No, you just check that. All right, so I'm going to break it at -1. All right, and then I'm going to keep going all the way through 3. Oh, wait a second. We said right here, x could not be 2. -2 is not in the interval, so I didn't care about that. So I'm going to have to break it at the 2. And then I'm going to get to the 3. Now, was it continuous at 3? You checked it. What did you find out?
It wasn't.
It was not. Break it at the 3. And then after that, you just head to infinity. Are there any other places I got to worry about? Ooh, the 6. So I do have to break it at the 6. So a lot of issues with continuity here. Now, when it comes to domain, is something, let me ask you a question. Is something like this, if this went forever to the left and forever to the right, what would my domain be?
All the numbers.
It'd be all real numbers, right? Doesn't matter if it's continuous. Were any of these places not continuous but did exist? The -3, I gotta break it there. But look, the -1 actually never was equal. Oh, but the 3 was. So on the domain, do you see how I'm changing this a little bit? On the domain, at 3, I don't have to break it. Now, I still have to split it up at 2, but I do not have to break it at 3 because there was something there. Are y'all with me? So I'm going to go, all right, skip over the 3. But domain looks a lot like continuity, but you get to accept jumps and holes that have points over them. I don't have to split it there like I do with continuity, because continuity has to meet all 3 conditions. For a domain, the only condition that has to be met is, does the function exist there? So yeah, you still got to break it at a lot of spots, you know, that don't exist or that have VAs, but not as many as you might think. What do you think? All right, hey, do the best you can with the homework. Feel free to email me a question or two, and keep sending me, like, again, about every year or 2, I pick a new class and go through it. This year, I'm just surviving, so I'm not going to be able to probably change a ton of stuff. But if you have questions, at the very minimum, I can email you back and say, hey, don't worry about something like that on this test. Y'all have a good one.
Is it okay if I come 7?